And welcome everybody to the Daily Space Weather. Today we're talking about a solar flare, coronal mass ejection, and relativistic protons striking Earth here at the Smash News Network. Least busted name in news. And you can actually see the protons striking the LASCO C3 in this image. You see a thing that looks like blue streaks, as it took only about 3 hours for some of the ejecta from this coronal mass ejection to strike Earth. It was triggered by a C9.4 class solar flare, and it sent relativistic particles traveling at like 2% the speed of light straight at Earth. Well, not entirely at Earth, but some of the protons have already arrived. While you were probably sleeping, there was a small proton storm on planet Earth. So let's take a look at what was going on from Lagrangian point 5. Here's the view from stereo A by itself. A great view of the coronal mass ejection. If you noticed in yesterday's daily space weather video, the title included the words CME warning, coronal mass ejection warning, as we forecasted it once again. And indeed, as forecasted, there it is. Let's also take some looks at Lagrangian point 1. Now, we showed the composite imagery there. Here is the LASCO C2 imagery alone. It looks like most of the ejecta will actually miss Earth to the west. So this all came out of sunspot 2824. There was some flaring associated with sunspot 2826 as well. So this is Lagrangian point 1 here. We'll also show you just the LASCO C3 by itself, the more zoomed out view. And that solar flare occurred soon after 2300. Anyway, there's the view from the SOHO LASCO C3. And here's some more imagery. This is a composite of the Solar Dynamics Observatory, the LASCO C2, and the LASCO C3. So we've got some fantastic close-ups of this as well in a couple different wavelengths. Here's a full disk view in 304 angstroms ionized helium. And there are still some filaments suspended on the sun here. We can still see one that we talked about yesterday down here. And there's still some filamentary material up here on the North Pole area as well. We also caught a crown prominence, a minor one. If you look right about here, you'll see a crown prominence. It was pretty small, but crown prominences are significant as they are typically seen at times of higher levels of solar activity. And here's a close-up of just the northern hemisphere in this same wavelength. Now, this incoming proton stream here showed up at the poles, more at the North Pole than the South Pole. And when it does this, it causes attenuation of the D layer of the ionosphere. This causes radio blackouts in these regions, the same way, similar to the way solar X-ray flares cause radio blackouts closer to the equator. The protons get separated into field-aligned currents. And this is why you can see the majority of the attenuation here to the D layer of the ionosphere happened at one pole and not the other. So that's interesting. It does give us some insight into how this material behaves when it shows up. When the solar wind strikes the magnetosphere, it needs to pick a field-aligned current. And it picked more of the North Pole than the South Pole, but you can see some complete blackout happening here south of Australia. And that has now subsided, by the way, folks. And if you were a patron, you may already know that, as we already sent out the alert. So here's a diagram of the solar system, if you're wondering what's going on here. There's where things will be in a week. Here's a star chart I like to draw in the ecliptic. That's the yellow line, the sun path across the sky. It's in-the-sky.org. You want to make your own star chart, put in your location there, and it will draw it for you. The radio flux, the 10.7 centimeter radio flux, the 2800 megahertz radio flux, still only at 77 solar flux units. Here's a one-year chart of the 10.7 centimeter radio flux. To put it in context, it's this black line. Again, it's at 77 solar flux units. And we're expecting some ejecta from this coronal mass ejection to strike the Earth once again. I would say midday on May 31st, as it is a high-speed coronal mass ejection to say the least. And this is seeing some of the ejecta show up from the coronal mass ejection that quickly is the thing that happens. It's been known to arrive in as little as 20 minutes, and here you can see the short period of S1 proton-induced storm conditions there, showing up in the geomagnetic activity report on the Space Weather Enthusiast dashboard. Let's take a look at seismicity. Here's the great chart from volcanodiscovery.com. That's the year-to-date seismicity. By the way, you can embed this in your website also. Here's the 90 days of seismicity. And no major quakes over the past 24. There were a few in the 5 magnitude range. Looks like 5 of them in the 5 magnitude range. Also, we saw some earthquakes in the middle of Lake Tahoe. And there they are, including this 4.2. So right near the California border there in Lake Tahoe. A small earthquake swarm there, the largest of which appears to be this 4.2 magnitude. Leave us a comment if you felt that quake. Somehow I doubt you did, but in any case, I'm going to scroll up the rest of the list here after I zoom out. And here's the USGS website's list of the past 24 hours of earthquake. Vanuatu saw one of those 5.1 magnitude earthquakes. Stanley, Idaho saw a 3.3 magnitude quake. Leave us a comment if you felt that. There was a deep quake near Nicaragua, near La Paz Centro. That was at 129.6 kilometers. And there's that 4.2 that came in at 15:25 Universal Time yesterday, 25 after 3 Universal Time. Colombia also saw a deep quake. Also, the Philippines saw a deep quake at a 4.6 magnitude over 560 kilometers depth. Timor-Leste also saw a 4.1 at over 110 kilometers depth. Chile saw a deep quake at a 4.5 magnitude at 108 kilometers depth. Indonesia saw a 5.1. Tajikistan saw a deep quake at a 4.4 magnitude, nearly 200 kilometers depth. And that's the earthquake list. No major quakes. And the volcano list looks like it hasn't been updated here. We're just going to say Etna likely still erupting. And a quick public service message. Do not pole vault the caldera. You are not Steve Stimpak. You do not have the capabilities to pole vault calderae. It's a very dangerous undertaking, and we want our viewers to be safe at smAsho.com. So please do not pole vault the caldera. It could be unhealthful. Continuing on to some GOES 16 sun-facing instruments. And there was another C-class flare as well. This one almost an M-class flare, peaking out at 9.4. So a C 9.4 class flare is what was associated with that coronal mass ejection, and it was a long-duration flare. If you look at it on the 6-hour chart, let's look at it on the 1-day chart. You can see it was a rather long duration there, and we usually show the 3-day. Let's go back to that. Okay, there we go. There's the 3-day chart. Don't be surprised to see additional coronal mass ejections, as there are still major filaments in between the Earth and Sun. So here's this proton event, folks. I'll show you the 1-day chart of that. It was briefly into warning territory, which is simply 10. So 10 to the first power, and that's particles per centimeter negative squared. Anyway, put up the 3-day chart. There's the 3-day chart once again. And yeah, coronal mass ejection was straight up forecasted yesterday. If you didn't watch yesterday's daily space weather video, perhaps check that out to see our forecast. GOES magnetometer's got some spikes in it here, and we're going to expect to see additional spiky readings here in the GOES magnetometer because not only is there a bunch of plasma in between the sun and the Earth, there is also heliospheric current sheet boundary crossing in the making. So it hasn't happened yet, and it's taken its good old time. Here's a visualization of that. And we were expecting a South Pole current sheet to come through, but it's not here yet. And so we're likely to see some additional weak magnetism. Don't be surprised if this sparks a geomagnetic storm also, folks, as the Earth's potential field surface source line, shown here in orange, snaps across into a South Pole-oriented current sheet. It could happen suddenly and with no warning. Keep in mind this data was 1 hour and 15 minutes old when we shot the video. Anyway, that's the top view ecliptic plane field plot. And if you're a new viewer, this data comes from 51 ground-based magnetometers, the National Sunspot Observatory, as well as magnetometers on stereo A and B located at Lagrangian point 5 and 4, respectively. Next, the line of sight ecliptic plane field plot. And you can see this South Pole current sheet on its way here, shown in red. Green current sheet is the North Pole-oriented current sheet. And we'll also show you the sun's B field here. Here's the sun's B field, the line of sight coronal hole plot. And surprisingly weak coronal hole activity here, a lack of coronal holes, including transequatorial ones, a lack of coronal holes going on, as cycle 25 is really taking its time to progress here. Here is another data set here, detected filaments and detected sunspot groups. One thing I'd like to note, folks, referring to things in space as plasma is basically a non sequitur, because practically everything in space is plasma. Now, there are some neutral particles out there, but in space, material only has to be about 20% ionized to be considered plasma. And with all the radiation in space, as most areas are not protected by magnetospheres, if there's a bunch of gas and dust floating around, chances are it's plasma because it's been ionized by all the radiation. I would also note that on this detected filaments, it's not really showing a lot of the filaments. I'll draw them in. There are some like this. And those could also eject over the next day or so. I'm not going to say a warning yet, as I don't have sufficient data to say that. Maybe I'll make another video later. Here's the planetary K-index, a measurement of global geomagnetism. Currently only at 1. Again, don't be surprised to see this get into geomagnetic storm conditions, as there is quite a bit of activity out there. The crossing of the heliospheric current sheet polarity. Next, the real-time solar wind. And you can see this little spike here in the solar wind density. The signal where the coronal mass ejection happened was right here. We did see a minor shift in the BTBZ, the total field and orientation to a pole. Anyway, current conditions only nominal here. No significant high speed or high density solar wind. Solar wind speed 404 kilometers per second. Solar wind density 5.76 protons per cubic centimeter. Here's a 4-hour geospace magnetosphere movie showing you magnetohydrodynamic pressure. And no major breakouts being shown in this. I'm going to let that play through as it refreshed. And we don't edit the videos in order to get them out as quickly as possible. We are used to making them live anyway, folks. So occasionally I've been known to make a mistake. I just try to correct it in real time instead of increasing the amount of time it takes for me to get the video onto your screen. I would also invite you all to watch me on Instagram. If you don't follow us on Instagram, you'll be missing some of the content. Instagram.com/smAsho. There's lots of exclusive stuff there. And here are ground magnetic perturbations, our second geospace magnetosphere movie, Geospace Delta B, showing you changes to the Earth's B field. We showed you the Sun's B field. Now we're showing you Geospace Delta B, which is changes to the Earth's B field measured in nanotesla. And congratulations on surviving a polar excursion, a geomagnetic excursion, so far. Now today's cosmology segment is going to be a separate video. So we wanted today's daily space weather video to be by itself and for it to be as short as possible since there's some pretty serious stuff happening right now with coronal mass ejections. Here's a teaser of what's going to be in the cosmology segment. There's duct tape involved. So make sure you tune in for that later in the day, our cosmology segment, and check out our previous cosmology segments. They have been fascinating lately. Let's get back to data. Here's a diagram of the Van Allen belts and distances to things like spacecraft in miles. Feel free to pause the video. Electron flux out in space can cause satellites to charge up, and we don't see any charging hazards right now. Here is the 1-year chart of the electron flux. And here's the 3-day chart. Nothing to write home about there. Nominal levels of electron flux. And the forecast is for a mild uptick. I would not tend to disagree with this. The green boxes are the forecast and the yellow diamonds are the observation. Next, the total electron content forecast. This gives you an idea of where GPS errors are most likely to occur. Everything fairly normal when it comes to this. Some minor nighttime anomalies here happening once again over places like Africa and the Central Atlantic, Central America, and Northern South America. Otherwise, fairly normal total electron content forecast. Here's a diagram of the atmosphere. Once again, a different diagram in kilometers. And we're showing you this to show you the F layer right there, located at 300 kilometers, because here's an animation of that. So you're actually looking at 2 days here, and we've been seeing some anomalies in the ionosphere. We've documented it on previous space weather videos. We're seeing some pretty low frequency modes here of the ionosphere. And for you new viewers, this is showing you vibrational frequency in megahertz. This is basically the bridge between the Earth's more dense atmosphere and space. And there are a lot of chemical reactions going on there. And there's a lot of vibration happening, especially under the sun. So over your head at noontime, especially around the equator, there's quite a lot of activity going on up there, which is invisible to the naked eye. Here's the latest image coming in at 9:30 Universal Time. A very low frequency ionosphere at that moment, only making it up to 9 megahertz. Today's meteorology segment is going to be separate as well. We'll just make a separate video about that. We want today's daily space weather to be a little bit shorter. We'll show you a global lightning map as a teaser here at the Smash News Network, least busted name in news. There is the global lightning map. Perhaps some of you consider this space weather. I'm not sure if I disagree. Let's do bonus features before we close this thing out. So our first bonus feature is going to be some hydrogen alpha imagery from a ground-based observatory. So the Gong 2 data. We're going to look at El Teide, Spain's ground-based solar observatory. This data is about 7 minutes old from when we made the video. Again, you can see the large plasma filaments up here and down here. Also, there's one over here that are still on the sun and have not yet ejected. The possibility for those to eject is still there. Here's the latest imagery of sunspots. It's the solar intensity gram. There's sunspot 2824, which has degraded since yesterday. It still does have the capacity to put out some significant solar flares, as it is still a beta-class sunspot. It has a North Pole umbra and a South Pole umbra. significantly increasing the probability for solar flares. Here's some more close-ups. Actually, before we do that, if you're new to the channel, please don't forget to press like and subscribe. Tell your friends, your foes, your science noobs and science pros about the channel. Nobody else is able to forecast coronal mass ejections. You know how I know? Because if they could, they'd be doing so. YouTube.com/smAsho. Also, check out our playlists. Next, thanks to our patrons, the true source of funding for the content. Patrons, without you, the likelihood that these videos would still exist would be significantly lower. And if you'd like the earliest alerts, multimedia, and all kinds of other perks for being a patron, patreon.com/smAsho is the location to do that. Tiers starting at $3 per month. And here are some more close-ups of the local yellow dwarf. Leave us a comment. Let us know what your favorite star, or perhaps your second favorite star, if it's too obvious what your favorite star is. 335 angstroms, this lovely blue artificial color imagery from the SDO, is one of the ultraviolet light emission spectral states of ionized iron. I'm not sure which one. Never memorized, something you can look up. Great view of that nearly M-class solar flare there. Here's a spectacular view in 131 angstroms. You're going to see essentially a transfer of plasma. It looked like a bunch of plasma went from sunspot 2824 over to sunspot 2826, which has now set and lost its name. By the way, thanks everybody who's leaving comments with things like predictions, forecasts, etc. Don't forget to leave a comment if there's something that sparked your interest in the video. Here's 171 angstroms, my favorite wavelength. More spectacular SDO imagery here. And you can see those magnetic field lines associated with that ionized spectral state of iron making their way from one sunspot to another. So some magnetic reorientation going on there before your very eyes. Absolutely spectacular. And this might be the best view of all, folks. I saved this for the last frame of the video. It's 94 angstroms. Just a spectacular view of the phenomenon associated with that coronal mass ejection, which, when you weren't even looking, it sent material all the way to Earth, which arrived in only about 3 hours. So in any case, thanks again for tuning in, folks. Congratulations on finding out that our channel exists. Cheers. And may that solar wind be at your back.